Hello everyone. So in this e-lecture we are going to discuss the topic the wind energy, which is part of the power generation subject of the 8th semester mechanical engineering branch. So move to next. So wind energy. So first of all we will understand what is the wind. Wind is the moving air or flowing air, or we can say the air in motion is called the wind. Now wind is a type wind energy is a type of renewable energy, and all the renewable energy except two form of energy, one is the tidal power and another is the geothermal power, are ultimately comes from the sun or sun's radiation. Directly or indirectly, uh, those renewable energy comes from the sun, except these two, tidal power and geothermal power. Now the sun, which transmit the energy on our earth, and that estimate of that energy is in the tune of 1.74 into 10 to the power 17 watt per hour, that received by the earth. Out of this energy, approximately 2% of energy is converted into the wind energy. This is a sentence which is stating that about 2% of sun's energy or sun's radiation energy is ultimately converted into the wind energy. This sentence itself specifies that how the wind energy is naturally generated on the earth. Many of you are already aware that how wind energy is naturally generated. So if you are not aware of the thing, then here we are understanding how the wind energy is generated. The wind energy is generated by differential heating of earth surface and atmosphere. That means there is some part of earth and there is another part of the earth, and if they are differentially heated, then there will be change in the local atmospheric pressure due to change in temperature, and ultimately there will be flow of the air, as we are aware that air flow from high pressure zone to low pressure zone. So ultimately wind is generated, and that is generating from differential heating. That means heating from solar radiation. So this is how the wind is generated, and also flow of wind is affected by the earth's rotation as well as contour of the land. That means if the land is plain, land is rough with some steep rise or in some steep fall, all those parameters will affect the velocity of the wind or quantity of the or magnitude of the velocity. Okay, next, the thing which we have already discussed, that the wind is influenced by the ground surface at the altitude up to 100 meter. That means from the earth's surface and up to 100 meter, the wind velocity is affected by the ground surface, nature of ground surface, whether the surface is rough, whether surface is some steep rise. It is almost similar to what we have studied in fluid mechanics, where how fluid velocity changes over a boundary surface. Similarly, here air is how air velocity is affecting at the earth's surface when flowing. Okay. Wind is slowed by the surface roughness and obstacles. Okay. Now this wind, we have received the wind velocity, and this wind is ultimately converted into the other useful form of energy, whether it is in electrical form or on any other form, with the help of a wind turbine. And the function of the wind turbine is to convert this flow velocity of the wind into a torque, a turning force, and ultimately it converts into the some other form. If we couple a generator, then it will convert it into the electrical energy. Now the amount of energy which the wind transfer to the rotor, okay, the amount of energy which wind transfer to the turbine rotor depends upon the density of air, the rotor area, and the wind speed. These are the three parameters which we will discuss in later stage, that how the energy generated by a windmill or wind turbine depends on what are these parameters. These three parameters are there: the density of air, rotor area, and the wind speed. Okay, now move to the next. Windmill. Windmill, what is windmill? Windmill is just a combination of all the setup that includes the wind turbine and generator and the supportive structure all together form a windmill, and it will ultimately convert the wind energy into the electrical energy, so it is called the windmill. Okay. The windmill captures wind energy and then uses a generator to convert into the electrical energy, and then all these designing parameter which a windmill designer have to decide, that how much the size of turbine and the size of the generator. Now the wind turbine have number of blades. That blade may be of 1 number, 2 number, or 3 number, and most of the turbine are having 3 number of turbine blades, and it is a stability parameter which ultimately governs the stability of the turbine, and most commonly design is of 3 blade turbine, and reason why we are selecting 3 blades is the stability of the turbine. And how the 3 blade will stabilize, it is similar to if we use 2 blade turbine, then the top blade which receives the highest amount of the air and will deflect backward, and at the same time this bottom blade will come in line with the this tower of this turbine, so it will not impart that much amount and there may be some stability issues. So 3 blade turbine is considered to be the most stable form of the turbine and widely used in the commercial as well as other applications. Move to the next. There are two broad classification of this wind turbine depending upon the orientation of the rotor blades. These two orientations are, one is the vertical axis and another is the horizontal axis. This vertical axis and horizontal axis are the axis of rotor. If the rotor axis is horizontal, then we call it as the horizontal axis turbine, and when the rotor axis is vertical, we call it as a vertical axis wind turbine. Okay, depending upon the pros and cons of each type of turbine, for commercial generally a horizontal axis turbine is used. So why vertical axis turbine is not that much feasible as compared to the horizontal axis turbine? So we are going through the pros and cons of this vertical axis turbine, and we will discuss ultimately the horizontal axis turbine. The advantage is of vertical axis turbine is omnidirectional. That means it accepts wind from any angle. Okay, that means a horizontal axis turbine will have some one direction from in horizontal direction, one direction, but a vertical direction rotor accepts since the blades are in such a way that they receives energy wind from any direction. Components can be mounted at ground level since it is having a vertical rotor, and we know that generator is coupled at the end of the rotor, so it can be coupled at top of the rotor or bottom of the rotor. But since we have the advantage of having it vertical, we can mount generator at the bottom of the this axis or rotor. So it is very much easy to repair and maintain and install the generator at bottom of the or at the ground level. Okay, so there will be some advantage like ease of service, lightweight towers, and can theoretically use less material to capture the same amount of wind. It is a technical parameter. Now come to the disadvantage of vertical axis turbine. Rotor generally near ground where wind poorer. That means rotor जो है वो आपका, if it is vertical axis, then the rotor will be at near the ground. So we know that near the ground there are several factors which affects the wind velocity. So we will get poor air velocity, poor this velocity of the wind near the ground level. Then poor self-starting capabilities due to its vertical configuration, requires support at the top of the turbine rotor, then requires entire rotor to be removed to replace the bearing, then overall poor performance and reliability, and commercially it is not successful. So in the most of the cases, for commercial purpose, a horizontal axis is being used. Now come to the depending upon the size of generating units, we are classifying here this windmill into the three categories. One is the small size of the windmill, then intermediate size of windmill, then large size of windmill. Small size of windmills are windmills which are of less than 10 kilowatt capacity and generally used for homes, farms, and some remote applications. For example, water pumping, some telecom sites, and ice making. Intermediate size windmill which are having capacity from 10 to 250 kilowatt and can be used, some of the application here mentioning some village power, distributed power, like that. And the large size of the windmill, large capacity of windmill, they are having capacity greater than 250 kilowatt and plus 2 plus megawatt. Up to that size of windmills are categorized in the large capacity of windmills, and they are generally central station wind farms and distributed power, and generally all of them are generally grid connected windmills. Now the wind energy, the technology. First of all, most important parameter for installing the windmill is the site selection, because we know that wind energy will be produced by wind velocity. When we will discuss the wind power, we will see that there are three parameters of which we have already discussed. Out of these three parameters, one parameter is the wind velocity, and power generated by windmill is directly proportional to the cubic power of velocity of the wind. Now velocity of wind we should achieve maximum, and for achieving the maximum wind velocity we have to decide a appropriate site where we should install our windmill. So here from graphically and from some diagram we are understanding that where a wind turbine should be installed. Okay, so good site means when the bottom surface is smooth and smoothly rising, and at the top of that we can install a wind turbine, okay, because it will create a speed up effect over smoothly, like it is a converging nozzle, okay. And at the this side there will be some turbulence due to boundary layer separation phenomenon which occurs in the, we studied in the fluid mechanics, similar to that. If if wind turbine is installed over a bottom of a cliff, where there is a cliff on the bottom or a sharp ridge is present at the bottom, in that case a turbulence will be created at the top of the surface, and it is not a good site for installation of the windmill. And here we know that in the uh, in the area of the flow of the wind there should not be any obstacles, because obstacle also affect the wind velocity and it creates a turbulence in the wind, and which will ultimately create non-uniform velocity at the site of the windmill, and which we know if some fluctuation or turbulences will be there in the air, then that will ultimately affect the performance and reliability of the system, because turbulence create vibrations, and that will ultimately harm the your this wind turbine. Move to the next. Here is a demonstration displaying how a obstacle creates turbulence. Obstacle create, here is the house, mentioning a house of height h, and this create a turbulence region up to the 2h height from a distance up to this 10h distance from this house. 2h turbulence up to 10h distance. This is a representation how we should avoid some obstacle between in the direction of the passage of air which strikes on the wind turbine. Now, calculation of the wind power. We have discussed three parameters and we are incorporating those parameters into the formula power in the wind. Here we are discussing wind power and not the power generated by the wind turbine. The wind which is near to strike on the turbine, which is having this much of power, and this power is represented by half rho a v cube. Here rho is the density of the air, a is the swept area. Swept area means the if blades is rotating, then how much area is it sweeping, and that is effectively, if r is the radius of the blade, then this area will be pi r square, and v is the velocity of the wind, and v cube is there. That means the change in velocity will abruptly change the quantum of power which will be striking on the turbine. Now, how much energy this turbine, how much wind energy it will generate will be multiplied by a factor Cp, that is Cp a factor which will define the out of this wind energy, how much energy is ultimately striking on the blades, and out of that how much it is converting into the torque. That overall factor Cp will be there, and that will be the amount of energy produced by the wind turbine. And after producing that energy, there will be some sort of losses in the bearings, that is known as your mechanical losses, and ultimately come the brake power of the turbine, and ultimately there will be a generating unit connected, this generator, and generator will also have some sort of losses, and finally we get some energy. And overall efficiency, if we will calculate, then this will be of the power generated by the generator divided by the power in the wind, this half rho a v cube. This will be the overall efficiency of the windmill. When we talk about the overall efficiency of windmill, that means the energy generated is the last part, and that is your generator. Energy generated by generator connected with the wind turbine divided by the power in the wind. Okay, A is the swept area that we have already discussed. Come to the importance of wind speed. We have already discussed how much important is the wind speed, because it is in the form of V cube. Okay, now come to the next. Overspeed protection. That sort of protection for the overspeed in case of some violent velocity occurs due to some occasional environmental issues, and for that we have to make some protection, that is overspeed protection, the part of the windmill. Then some images of the we are showing some images of the wind turbine from initial invention to the today's modern latest design. Is the early windmill in Afghanistan 900 AD. We are showing some sort of picture here. Then after that, continuous evolution in the technology, and Jacobs turbine, which was in the era of 1920-1960. Then Smith-Patterson turbine of the two-blade turbine in the era of 1940, and some sort of blade profiling. Here is a layout of the wind turbine power plant. There are several wind turbines and generators are connected, and ultimately they connected through some sort of transformers for voltage regulation, and ultimately connected to the grid lines. This is offshore wind farm mounted in sea. All these are offshore. Then floating wind turbine concept. There is means entire this machine is floating on the sea, and why we are installed it in sea, that we can use this sea area or for saving of the useful land. Now the advantage of the wind power. We know that wind is a non-conventional method of generating the power. So what are the various advantages we are discussing here? The wind blows day and night, which allows windmills to produce electricity throughout the day. Unlike that of the solar energy, which is also a renewable part of energy, where in night we are get almost negligible amount of energy can generate. In the wind power generator, wind power mill, we can generate the energy throughout the day and night. Wind power is available in ample amount in all coastal areas. There are some specified sites where wind speed is quite good and smooth and uniform. We can get this wind power very much easily. The decreasing cost of wind power and the growing interest in renewable energy sources should ensure that wind power will become a viable energy source worldwide, which is actually happening, which we will show how it is happening from data. Now come to the environmental advantage of wind power. What are the environmental advantages, or how this wind power is environment friendly, that we are going to discuss here. It does not produce any carbon dioxide or carbon monoxide, since it does not burn any kind of fuels. It is a renewable energy. There is no use of fossil fuels. Almost 95% of land in use can be used for farming or recreational purpose. That means the site where this wind turbine or windmill is installed, a minimal location we can use, and on the other all other surrounding location we can do the farming or recreational or any other normal use we can do of particular land. Now here is the statics, which is showing how this renewable energy is growing year on year. So here is a statistical data for the wind energy in the fastest growing energy source in the world, uh, even fastest than that of the solar photovoltaic. Okay, so here is the statics of average annual increase in percentage in installed capacity from 1993 to 2003, and we are saying that average annual increment of 29.7% in case of wind over these 10 years, and in case of photovoltaic it is 21.6. Natural gases and all this conventional form of energy is having almost a very small and steady growth, whereas we are having heavy growth in case of these two form of the non-conventional or renewable form of energies. Now come to the key environmental issues facing wind power. Since it is a renewable energy and environment friendly energy, still we are discussing some of the what are the some environmental issues we are facing for wind energy. And since we are facing some environmental issue, but without any comparison, if we draw that if we are facing particular this, but how much is that? So each and every issue we are comparing with the compared to the other parameters, other form of generating energy or other machinery like that. Here is the one key parameter which is in the initial is, since the wind turbine has movable blades, so there is a chances of some birds striking the blade. So this is a parameter in which the annual bird death is compared with the other type of incidents from where these bird death are occurring, and we see the glass windows from by striking to those, and electric transmission line collisions in house cats, hunting, automobiles, agriculture, communication towers, and all these parameters how they are affecting the bird death. And in comparison to that, wind turbine is getting very much minimal that bird death, but still there is this bird deaths are occurring due to this wind turbine moving blades. Now come to the impact of wind power noise. One parameter is noise pollution, that is very much less compared to the other form of generating the power, but still there is. So the modern turbine are relatively quiet, the turbines are very much quiet, but still if someone is living very much near to that, then some form of noise is generated, and that may pollute the environment nearby. So here is a comparison of the noise pollution by the various other machines compared to the wind turbine. Here we are saying a wind turbine is generating a sound of the order of the 40 to 50 decibels, okay, which is of the order of the normal bedroom, means if fan is on, and how much the noise is generating, or a less than that of a home sound due to some kitchen appliance like that. It is very much less and can be easily manageable. Then come to the slide. Here attractiveness. There is one more parameter known as attractiveness. What is this? We are reading here. The large windmill generate more electricity but moves slowly and so have less attractiveness among people. Okay, there are less attractiveness among people, whereas the small windmills have more attractiveness but generate less electricity. The concept behind this is that in windmill what we have to generate is the torque to move the turbine. Okay, we need torque and not need the speed. So a small windmills generally have larger velocity, whereas a large windmill have relatively less velocity of the blades, but they produce more torque. Okay, so here it was a brief description of the wind turbine. Any question or any doubt you can ask through my personal email or by directly messaging me, and we will come up with next class. Thank you very much. Thank you.